this last segment. If triangles are similar if they have the same shape, but not the exact same size. In other words, they have to have the same angles, but not the same length of the sides. So the properties of similar triangles are their corresponding angles are the same. So let's draw one. Let's see. I have a little triangle and then a bigger triangle. And as long as these angles are the same, these two angles are the same, and these two angles are the same, I can say that those are similar. It's just like going to a photocopier and making it larger. The sides, though, are corresponding in proportion, so they're proportional to each other. So if this side is 1 and this side is 3, this side would be 2. Well, I've tripled to get to the bigger triangle. That means this side would be 6. So you can see how what this means by the corresponding sides are proportional. They're multiplied by the same factor. Okay? We can prove that triangles are similar by using a couple methods. The first one is angle-angle. So if we know that 2 of the angles match, then we can use the angle-angle postulate to say that the triangles are similar. Okay, we can use side, 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 the SSS of similarity, meaning all 3 sides are proportional. So I could say in this case, let's see, if this is 1 and this is 3 and this is 2 and this is 6, and let's say this is another 2 and that would make that another 6, then I could say all my sides are proportional by saying, okay, 1 is to 3, which is equal to 2 to 6, which is equal to 2 to 6. Are all those congruent to each other? And yes, each one of these corresponding sides are proportional in a 1-to-3 ratio. So that's what the side, side, side is. Okay, and the third way is side, angle, side, meaning that 2 of the sides are proportional and then the included angle is congruent. So the sides are not congruent, but the sides are proportional. So you could say 1 is to 3 and 2 is to 6, and these 2 angles are congruent. Okay, so that's kind of how you can use properties to show that triangles are similar. Okay, a common internal tangent intersects the segment that joins the centers of the 2 circles. Okay, so we've also got a few things on internal tangents and how we can create some similar triangles. Okay, we've got 2 circles here, and we've got this segment AB, and AB is connecting the centers, but it's an internal, it's just connecting it's a segment connecting the centers. The internal tangent is RS. It's tangent because it's touching circle A at R and it's touching circle B at S and touching one spot. Well, we know that if we have a radius touching a tangent segment, we have a right angle. And so let's draw that one over here too. So that means we have the angle S and the angle R have to be 90 degrees because they're tangent to the circle. Okay, what other information can we get from the diagram? Well, notice we have vertical angles here. This angle has to be congruent to this one because there we have straight lines going through point C. So we have the angle-angle postulate, meaning that's one of the ways to show they're similar, that 2 angles are congruent, so the triangles must be similar. So we can then set up, well, A is to C as B is to C, because they're the corresponding parts. RC is to SC, and those would be proportional sides. The third set of sides that would match or be proportional would be the radius. AR would be to BS. You could set that third side and check for similar ratios of sides. So there you go. That's the end of the tangent and similar triangle segment. Hope this video was helpful for you to see those properties of similarities and how to solve some of these more elaborate party hat problems.